hello. I know you're all going to be in a food coma, so if you fall asleep, that's fine. I'll know that you're enjoying your afternoon. I'm Gemma, and this is Testing Spaghetti. I'm not like an interesting person in the PHP community. I'm not a core dev. I don't work on extensions or anything like that. I'm an end user. I got started at Cornell because I had good family connections. And that's really the only reason, which was excellent. I spent, I don't know, 6 or so years in the postal mailing industry doing C, ANSI C, C89C, not even like C99, C89C. And now I work for Proxy, which is a provider of global proxy services. If you're interested, come talk to me. But this is not about that, don't worry. I've done PHP 4 back in the day. Now I do a lot of PHP 5, as do we all. I've also done Visual Basic.NET, C#.NET, Python, Java, Go, Delphi, a whole bunch of very many languages. I'm not super interesting, so we're going to talk about pasta. So this is where we all exist in PHP land. Who is currently working on a legacy PHP project? Look at these hands. Ah, my sympathies, and I'm glad you're here. Who has worked in the past and is not currently, and is like thanking their lucky stars they're not currently working on PHP, on legacy PHP, a couple hands. See, that's 2 people, you guys. So when we say spaghetti code, what exactly are we talking about? This is the earliest reference that I could find, and it's way the heck down at the bottom. You probably can't see it. Denny Van Tassel, 1974. He was a CS educator. This quote is from his book, Program Style, Design, Efficiency, Debugging, and Testing. And I like this quote, which you may not be able to read if you're all the way in the back. So it says, large monolithic programs are like a plate of spaghetti. Pull it here, and something moves on the other side. I like this quote because that's not actually what I think of when I say spaghetti code. When I say spaghetti code, I mean I'm usually talking about internal structure. He's talking about side effects. So it's almost like an indictment of non-functional languages. So I thought that was interesting. This is 4 years later, Richard Conway, 1978. This one is more familiar to me. Code having the same clean logical structure as a plate of spaghetti. So now we're into internal structure. This is a mess. This is just a quote I pulled off a blog that I thought was good. I don't really know who Michael O. Church is, but he said good things about spaghetti code. Incomprehensible unless one has the discipline to follow each noodle through from one side to the other. So the first one was sort of side effects and external, what's going on. The second one was internal structure. This one is about comprehensibility, readability. So sort of three aspects to spaghetti code that all basically mean it's bad, don't do it. Canonically, in 1974, this is what they were talking about when they said spaghetti code. And of course, the thing to note here is the go-tos, which we have in PHP. Isn't that great? Isn't everybody super happy about the go-tos we have in PHP? So this logical structure here is a little rough. It's a little windy. It's a little noodly. Hard to follow. You can imagine several thousand lines of this. This is bad. And this is what Van Tassel was talking about. As it turns out, there is an entire taxonomy of programming pasta on Wikipedia, which you'll find if you Google Wikipedia spaghetti code, and you'll see the whole list. Somebody asked me the other day what ravioli code was, because I knew that was something, and I looked it up so I could answer that question. Ravioli code is very small modules, tightly encapsulated, very loosely coupled. That's ravioli code. We're not going to talk about ravioli code. That sounds wonderful. We're going to talk more about macaroni code, which according to Wikipedia is languages all mixed together like macaroni and cheese. So you've just got everything in one place. Or as I like to call it in PHP land, SQL in all the things. Does this look familiar to anybody? I don't know. I hope you can see it. Can you guys see in the back okay, or is it terrible? Not really. I'll describe it. So this is classic XHTML 1.0 transitional. Who's done this? Yeah, all right. So we've got our doc type for the entire DTD up there, because this is 1999. We've got the beginning of our HTML page, and then we've got our short PHP tags, retro, and then we're just gonna right immediately, as soon as we started the render, we're gonna go grab the page title from the database with MySQL_query, everybody's favorite MySQL function. And we're gonna do some logic here. If we can't find it, we have a default. And then we're gonna keep rendering. We're gonna spit it out here. This is pretty standard. When I say spaghetti code, I'm talking about this. This is what I'm talking about. More of the same here. So now we're into the body. This is some sort of a blog. We're again MySQL_query. We're going to get some posts, and then we're gonna loop through the result set and just render each one immediately right here, and then finish. So this is not ideal. This is macaroni code. Who has common.php in their projects? Come on, 2 people, I know more of you have common.php in your projects. I do. So this is the classic. This is the, I don't know where to put this function, so I'm going to put it in common.php. I need to get a user by its ID out of the database. So I'm just going to create a function really quick. It'll take the ID. It'll grab the user out of the database. It'll return the associative array of the user details if I find it. Otherwise, it'll return null. No problem. I need to do it again. And this time, I have to check the password. So this time, I'm just going to wholesale copy paste what was in getUserById, throw it into this new function, and I'm going to add the password on the end. Obviously, there's some problems here, because we just copy pasted and didn't really pay attention to what was happening. There's no shared code here. This is not testable. None of this is testable. And as you can see, copy-paste errors are a problem, and they exist in this code. This is not production code. This is very close to what used to be production code in one of my projects, for the record. Here's another one. This might be farther down in common.php. We've got some business logic up here, and then we've got a MySQL query right here. So this is still not testable, which is a shame, because it's broken. So this is additional, common.php classic, still not right. And you're sitting there thinking, yeah, I don't have common.php, Gemma. I'm fine. I don't need to be in this talk. Well, anybody here use Bullet.php? It's a micro framework. No hands. Well, you should check it out. It's really cool. If you like Slim or you like Silex, Bullet is very similar. So up that first line up there, we're defining our pets endpoint. Here, we're defining what happens when you post, HTTP post to that endpoint. And this is essentially a controller. So if you use some other framework, this would be your controller. If you use Slim, this is going to look really familiar. And this is still spaghetti, in my humble opinion. We've still got some business logic happening. We've got a raw database query right here, more business logic down here. None of it's testable. None of it's reusable. Can you think of anywhere else you might want to check this stuff? Maybe if you need to edit a pet or something. Save new pet to the database. I ran out of room, so more SQL queries here. So we're using a framework. We're not in common.php, but we're still writing spaghetti code. So it's running. I mean, all that stuff was basically in production. It was working. It was fine. Why do we need to care? Do you need to care about this? How bad could it really be? It can be bad. As we saw, repeatedly duplicated code will will have errors in it eventually because you're not going to update it correctly for that context every single time, because you're human and you're going to mess it up eventually. So if you have the same like 5 lines that you're just copy pasting in 9 different places, in one of those places you're going to forget to change the variable and it's going to break and you're not going to notice. It's hard to read. It's hard to read. If you've got a comment.php that's like 5,000 lines long, which is conservative, it's hard to look at that as a new coder, as somebody who's new to the code base. As yourself in 6 months, you don't remember what you did. You don't remember where you put stuff or why. It's hard to read. And this is the other problem with the copy-paste errors. If you've got a bug in those 5 lines of code that you're copy-pasting in 9 different places, and you haven't found the bug yet, when you find the bug, you now have to go back through all 9 different places and fix the bug. Are you going to remember all those places? I don't. I'm not going to remember. I actually have a file on this laptop that's in my home directory that's literally called thingsIwillforget.md, because I don't remember things. And more often than not, I actually forget that it's there, so I go like Google the solution to a particular problem again and realize that I had already saved it. But this is the real problem with spaghetti code. It's not testable. You cannot test this stuff. When you're doing database queries right in the middle of your business logic, you cannot test that code unless you have a full database sitting behind it. And that's a problem. There's a reason that testability seems like it becomes the goal in a lot of these cases, and I'm going to prove it to you with science. If you're not on the testing bandwagon yet, I can see grumpy programmer who's totally on the testing bandwagon, but maybe some of you aren't. I'm going to prove it with science. So this is a study. I think this was in empirical software engineering. But this was a survey of 18 studies that were all sort of reviewing agile practices. So TDD, XP, Scrum, all kinds of stuff. Don't take the 15 here as a percentage of the 18 because not every study looked at TDD. But the 15, essentially the studies that talked about TDD showed extensive quality improvements directly resulting from test-driven development. This one is the classic study. If you do any academic research into testing at all, you will run, like modern testing, you'll run across this study. This was big projects, real projects, not case studies, actual production, real projects at IBM and Microsoft. They added test-driven development, 40% defect reduction at IBM, 60 to 90% reduction at Microsoft. How do you not incorporate that into your workflow? 90% defect reduction, that's insane. So another one, this one was just on unit test automation, not TDD specifically. If you're not on the TDD bandwagon, I'm really bad at it. I do a lot of testing, but I don't necessarily start with the tests, which I know is heresy. But this is just unit test automation, 21% defect decrease. And this is the one that you really want to bring to your manager, your boss, your CEO, CTO, whatever, CFO. The economics of unit testing. And this one's really important. If you find defects at the unit test level, it is orders of magnitude cheaper and faster to fix them than to find and fix them later. If you've already deployed the code, dealing with the defect is a much, much bigger deal. If you're interested, there'll be like full references for all these studies at the end of the talk. So the bottom line here is this. If you can't test your code, you're missing out, and so are your users. And if you have spaghetti code, you can't test your code. So we know what spaghetti code is. We know why it's bad. Let's see if we can fix it here. I'm going to pull back a little bit and talk about the tools that you can use to get this going, starting with Composer. Who's got Composer in their projects? A couple people? All right, most of you, great. I call it the package manager for people who hate package managers. Technically, it's a dependency manager, not a package manager, but it's close enough. it's wonderful because it really doesn't have any dependencies at all. If you're working with PHP, if you're doing a PHP website, a PHP project, you already have what you need for Composer. Unless you're on like PHP 5.2. Anybody on 5.2 or earlier? Couple, I'm so sorry. Upgrade, and then you can use Composer. I know, I've been there, I know. There's a theme here. No dependencies, no side effects outside the project. You don't have to fight with your sysadmin to get this on your development systems, on your staging systems, because it doesn't affect anything else. It doesn't require anything else. It doesn't affect anything else. It's fabulous. This I really like. This is very cool. It really has no opinions about how you're supposed to do stuff. So if you've got just a terrible, you've got some project that's got index.php at the top of the thing, and then you've got all these other random folders and directories, and everything's just totally unorganized, Composer doesn't care. That's fine. You can add it to any project, any stage. And really, the not having to fight with your sysadmin is lovely. If you've had to fight with your sysadmin about getting Ruby on your system so you can do like Compass, SCSS, or if you're getting Node on your system so you can use Grunt or whatever, Composer is lovely. None of that. This is how you install it. You pipe it directly from curl into PHP. Who thinks this is the best way to install things ever? No, wrong. Put your hands down. But it's on their homepage. That's my excuse. This is how they tell you to install Composer. Clearly, you should go look at it first, and then download it all the way, and then send it to PHP. But this is how you install it. And once you have it, this is it. And install. You're done. You now have Composer in your system. Vendor is the default location for everything Composer is going to pull down, so any external packages. And composer.json and composer.lock define what you need for your project. They're sort of metadata. If you've done things with npm, it's kind of like package.json, roughly the same. So now that we have Composer, we can get PHP unit. There are lots of other options, I want to say at the beginning. There are lots of other options for testing. Codeception, simple test. Anybody use simple test? Yes, yes, yes. Simple test was great. It was one of the first frameworks for PHP 5 for testing. It was so exciting. Way back in the day. But yeah, codeception, simple test, Bayhot, PHP spec, which is related to, I don't know, there's lots. The important part here is that you have something that gets you up and running quickly. I use PHP unit because it's what I'm familiar with, and it's worked for everything I've needed so far. This is how you install it with Composer, and that's it. Just that. Once you have that, once you've done your Composer require dev PHP unit, this is sort of an obviously stupid test here, testing that 4 is equal to 2 plus 2. So this is a 5-line class in test/mytest.php. This is how you run it, and that's it. That's all you need. You can make it more complicated. You can set it up with a bootstrap.php. You can set it up with a configuration file called phpunit.xml. It all depends on what you need in your project. This is all you need to get started. You run the executable that Composer gives you against your test directory, and you're done. So those are some tools, Composer and PHP unit. Talking about concepts a little bit. Who's familiar with Solid? S-O-L-I-D? Yes? Everybody. OK. Well, this is totally pointless then. You all know this. So this is the S in Solid. And I got yelled at once for just talking about the S and not the O-L-I-D. Sorry. There's a time limit. So the idea here is that your code should do one unique thing. Single responsibility principle means your code is responsible for one thing, and it's unique. And it matters because if you wrap one concept entirely in one context, in one set of code, that when the concept changes, only that code has to change. Only that code. Which makes maintainability quite a lot easier. It also makes testability easier, because if you want to test that concept, you only have to test that code in that context. Spaghetti code, untestable code, does a lot of things. It's responsible for a lot of things. So we're responsible for rendering the page. We're responsible for like structure of the page. We're responsible for talking to the database. We're responsible for some business logic. There's a lot that this code is responsible for. It's overachieving. It's trying too hard. You want your code to be lazy. And you can do that with dependency injection. Who's familiar with dependency injection already? I know, yeah, OK, basically everybody. Awesome. Why are you here? You guys know this stuff. Man. So what dependency? In this case, we've got a stupid little get template file routine here. This method is creating a new config object. I don't know what the dependencies of this config object are. Right now, it's just empty. Maybe there aren't any. But the config object, if I want to do anything with this function, I need this. And this has to be created here, or this is created here. So if I even wanted to test this function, it's going to create a new config object. And I don't know what this config object does. Does it talk to the database? Does it talk to a file? Does it need like a separate file that it reads config from? I have no idea. So the config object here, this is a dependency for this particular function. And if you want to test it, you have to know what you need to wire up first. So going back to the single responsibility principle, that code, this, is responsible not just for getting the template file name, but also instantiating this new config object here. OK. So we're going to take some away, some of that responsibility. Instead of creating the new config object here, we're just going to pass it in the function itself. So we're going to pass in both the template name and the config object. And then we can just grab the information that we need from here. If you're hardcore, you're looking at this and going, Gemma, you should have just passed in the directory name. Yeah, the first steps. It's OK. So if you want to test this, all you need is some sort of an object that you don't really know much about, you don't need to know much about, that has a template directory property on it. So when your code is only doing one thing, and all the dependencies that your code has are injected into your code, that means you can inject fake dependencies, and you only have to test the one thing. So in this case, we've moved our getTemplateFile function into like a new template class. So this is just a sort of a holder, just to give it a little bit of structure here. And here's a potential test method for this getTemplateFile. So we create our fake config object here. And remember, all we know about this is that it has this template directory property. So we throw a template directory property on it, and we say, OK, it's foo. And now we know, since we've controlled this, we know that when we call this function, when we do this getTemplateFile function, this is going to be our result. Does that not make sense to anyone? Any questions? All right. So that is the beauty of both the single responsibility principle and dependency injection. So those are our sort of our tools, our concepts. Let's get down to business here. This is really one of the hardest things for me when I'm approaching legacy code, and I want to fix it and make it better and improve things. Don't try to do it all at once. If you're anything like me, you look at that and you say, those should all be in a user object. I need a user object. I need to refactor this entire thing right now, put all of this functionality in a user class. Yes, you're right. Eventually, you're right, but you don't have to do it all right now. You can leave some of it there for another day, and that's going to be okay. So let's start small with just get user by ID. So this is I got to reach into the database, get user details by some ID. Create a pretty naive little database model here. I wouldn't recommend copy pasting any of this code into your own projects, but this kind of gives you the idea of where we're headed. So we've got details, which is going to represent the associative array of all the details that are in the database for this user. We've got our protected database, or underscore database, DB, that's going to be a MySQLi database connection. Who uses MySQLi on a regular basis? A couple people. OK. Better way to do this would be to use like PDO or Doctrine or something nice. But for this, we're starting small. This is the key here. We're just starting small. You can get up and running with MySQLi very quickly. Very, very low impact. So this is our big and exciting thing here. This byID method is a static factory method, essentially. So we're passing in our database. We're passing in the ID we want to grab. And then we've got all this error checking right here. Normally, like in actual code, I would have all these conditions like on separate lines, and it'd be very readable. But I ran out of space. So it's all kind of crazy. So we've got DB prepare. This is how you set up a prepared statement in MySQLi. Our query is going to look familiar, except for the question mark, because we're in MySQLi prepared statements now. And then we've got all of this checking we're doing. So if prepare comes back false, we're failing. If binding the ID parameter to the variable comes back falsy, we're failing. If the execute is falsy, we're failing. If the result is false, we're failing. If we can't find the user, we're failing here. And if all of this succeeds, if all of this is OK, then we create our new user object, and we're ready to go. Any questions on any of that? Anybody not think it's better than the original? Wants to fight with me? OK. So the really key part of this byID routine is that we're passing in a fake. Or I'm sorry, we're passing in our database connection in the method itself, which means we can make a fake one to test it. So this is just a very small test for that first thing, that very first condition that we check. This one right here. So if prepare comes back falsy, we're done. That's it. So in this test, we're creating a fake database connection with the standard class, which cracks me up that this is still in PHP, right? But it's still there, so that's fine. We're telling PHP unit that there's going to be a prepare method on this object. And then this is great, because you can read it like English. So we've got our fake database connection here. It's got some kind of a prepare method on it that we haven't really defined yet. The database expects one call of the method prepare to return false. So when this line right here calls byID with our fake database, when this function gets to the prepare method is going to return false. So we know that this is going to return null because our condition returned false. Anybody not tracking? Anybody have any questions? Yes?
So that's not, the expects function is not like an assertion, it's actually?
It's both, actually. It is an assertion. So if this, for some reason, didn't call prepare, I would get a failure of this test because it's expecting it. If it called it twice, I would get a failure because it's expecting it once. Does that make sense? It's setting up both the expectation that it's going to be called, and it's saying, by the way, it's going to return false.
Oh, okay.
Make sense? Cool. Any other questions? Yeah?
Why are you testing prepare? Is that not like you're testing the database, like MySQLi in this case? It makes sense more to test your business logic versus the prepare and statement.
This is part of my business logic because, yeah, you're right. If I were actually dealing with a real database object, if prepare fails, there's something wrong with the database connection.
I would just have a repository that returns the user.
Yes, but we're doing small steps. This is the key. Like, yeah, ideally you would want a repository. You would want a much bigger thing to really manage your database connection. But you're trying to actually get stuff done, and you just want to be able to test your code. So this is a relatively fast way to get to that point without having to, yeah. Oh, and I'm supposed to repeat the question because I'm being recorded. I'm sorry. So you had asked, can you say it again? Why are we testing prepare when prepare is the method on the database object? And we're testing it because it's part of our business logic and we don't have a bigger thing yet. Any other questions? OK. So we've got our beautiful test for get user by ID. So here's sort of our, just stubbed out the original so we can see what the interface was, what the inputs and outputs were. The original get user by ID took the ID, so it took some kind of an int or a numeric. It returned the associative array of user details. If we found the user, it returned null if we didn't. So here's our new one. We're using our static factory method here. If we find, this is sort of long just to keep it on one line. If we find the user, we're assigning it to this user variable. It's going to be truthy if it's successful, in which case we return the details. And if it's not, we're going to just return null, which exactly matches the original interface for this method. The key here is that we can keep using this method now. You don't have to go through your entire code base, find all the places that get user by ID was used, and replace them, and then do all the tests for all of that. We've just replaced the innards. So you can keep using get user by ID. This is now testable. I'm sorry, the user class is now testable. The user class will also be the foundation for more development in the future. So as you need to add more functionality, as you're fixing bugs or whatever, you can start moving additional functionality into your new class, add tests to it, and end up with a higher quality code base. And yeah, this is key. We didn't have to change the interface. The interface is the same, so we can keep using it. Any questions on any of that? All right. So number one was don't try to do everything all at once. Number two is don't quit your day job. You have stuff to do. You have managers who want you to do things. You have supervisors and CTOs and whatever. And they all want you to add value and not waste time on testing. And that's fine, because you can do that. You can refactor and develop at the same time. And I know this is heresy also if you're big into the real Martin Fowler refactoring. You're never supposed to change anything at the same time. I do. And it works, and it's fine, because you work in small increments, and you maintain interface consistency wherever you can. So just like we didn't have to change the interface of get user by ID, we do that a lot. So here's another. This is our other fabulous method from common.php. We're basically logging somebody in. We're pulling somebody out by name and password. Your manager wants you to make sure that inactive users can't log in. So the really fast, easy fix for that is and active equals 1. Done. No problem. I mean, I still have this problem, and it's still not even a little bit testable. But it's fine. Well, let's see what we can do. We happen to have this beautiful user class we just created like 2 minutes ago. So let's split this up a little bit into another static factory method up here. So this is going to be really similar to byId. You're probably going to start this out by just copy-pasting byId into byname, which tells you right there that it's an opportunity for refactoring. I'll leave that as an exercise to the reader because I want to get to the interesting part, which is moving your business logic here. So this one is not, you'll notice, is not static. We've already got an object, populated object of the user at this point, and we're just checking their data. So there's a lot of ways to do logins. Don't check passwords like this. There's many things wrong with this from a security standpoint. It's here as sort of a proof of concept to show that you can move the business logic out. If you're using PHP 5.5 or up, use the new and beautiful password underscore whatever library. If you're before that, use the password compat library that Anthony Ferrara did. It's wonderful. So this is a very naive implementation of a login. But the beautiful thing about this is that it's testable. So if the password doesn't match, we throw an exception. If the user's inactive, we throw an exception. And your perspective on exceptions as error handling and so on may be different from mine, which is fine. The point is that we've got our business logic out. So here's potential tests for this. And you'll see these annotations up here, this expected exception message. This is very cool PHP unit stuff that lets you throw an exception inside a test and confirm that it was thrown and that the message was right. You can also check the status code. It's nifty. So our first one, if our password doesn't match, so we're setting up our user with a password of password, and we're trying to log in with the wrong password, this will throw an exception that the passwords don't match. And that's what this tests. Same concept here. I'm going to walk right off this stage. I'm not. OK, it's fine. Same concept here. So setting up an inactive user, active equals 0. This time the password matches, because that was the first condition in our login function. And this is going to also throw an exception with the message user is not active. And that's what this tests. And we're only covering business logic here. These tests don't care about the database, which is lovely. Any questions on any of that? All right. There are other ways to do this as well in PHP Unit. You can do it inline in the code. I like this because it's kind of nice to read and it doesn't clutter up the code with extra cruft. But you can do it both ways. So this is going to look familiar, hopefully. So here's our original. The original interface was pass in the name and the password, return null if anything goes wrong, basically, and return the associative array of user details if everything's fine. Here's our new version. So it's a few more lines because we have to deal with this exception now. And I don't know why I put this on 2 lines instead of 1 like in the first one, but that's whatever. It's the same logic. If we don't find the user, we're returning null. If the login throws an exception, we're returning null. Otherwise, we're returning the details. So again, here, we're not changing the interface for get user by name and password. So we don't have to go find every instance of get user by name and password and change it. Any questions on any of that? OK. Any gamers in the audience? Yes! All right. Achievement unlocked, multitasker. You have now refactored old code and added new code at the same time, and the world did not explode. It's a miracle. So here's number 3. We've got, OK, well, let's see if I can remember. Number 1 was don't try to do all at once. Number 2 was multitask, basically. Number 3 is be sneaky. So this is our homepage from before where we're grabbing the title from the database. I don't know why you would do that, but maybe you would. This is problematic, obviously not testable, even though there is a little bit of business logic here. And if you're anything like me, you're looking at it and saying, model view controller, give me Zend Framework 2 right now. That is what I need to fix this immediate problem. Or not. So here's a naive implementation of some kind of a page model. It's going to look similar to the user class. So we've got our database connection. We've got our page details. We've got our factory method, which is going to look a lot like the by ID, by name. Sort of this is the same concept happening. And then to grab the title, we load the page. Once we have the page, we get the title if it exists and return that. Otherwise, we have default title. So that's all your business logic that was previously wrapped up in this MySQL nonsense. So what do you think? Is title testable? Anybody? Yes, it is testable. OK. So some simple tests just for that one title method. Creating a new page with no details that will have a default title. Because we didn't tell it what the title was, that title method is going to return whatever we said the default was. New page with an empty title. Again, we're going to return the default title because even though the title's set, it's empty, and we don't know what to do with that. So we're just going to return the default. And another test to check that if you actually set the title to something interesting, that's what gets returned. So we now have testable business logic. I mean, it's tiny business logic, but it's there, and it's testable. And we can throw it back onto the original page in all of its XHTML 1.0 transitional glory, just very simply, just sneaking it in under the radar, without Zend framework, without anything, really. Load the new page, or load the page that we're on, and get the title out. So this is still kind of macaroni code, you'll notice, because we're still doing, this PHP stuff and this HTML stuff, and it's all still here. But those are now testable. Any questions on any of that? OK. So here's really the crux of the problem. How do we get there in the first place? Why do we have all this spaghetti? How did this happen? It's faster. It's always faster up front to do the quick fix instead of designing a solution that's more maintainable. Every single time, spaghetti will win the speed race. Spaghetti also wins the how hard is this to conceptualize race. Design is hard. Structural thinking is hard. I am no expert. But I know that it's harder than just like adding active equals 1 to a SQL query. Systems thinking, design, structure, architecture, these are not the same skills as script hackery. And both of those things are important, but this kind of thing, spaghetti, is easier to start with. And this is really the big one. Your stakeholders don't care that your code is unmaintainable if it's working. They don't. Nobody cares. Your boss doesn't care. The QA people don't care. The end user doesn't care. Nobody cares as long as it's working. For whatever reason, it's easier for sort of the predominant customer-vendor relationship to have a long-term support contract than to just have fewer bugs in your code in the first place. They like having somebody there to fix all of the things that break when they do, instead of just knowing that their code is going to be better to begin with. So how do you stop it with this stuff? You really have to care about your code. And if you're working in a legacy code base, that's hard, and I understand. You have to care about the quality of your code base. If you don't care, you're probably in the wrong talk. But if you don't care, then just do spaghetti. And it's going to be a nightmare to maintain, and you're going to be miserable. And that's fine. You'll go home at the end of the day and do something else. It's fine. If you want to not have to have this horrible spaghetti mess, you have to care about the code. And you also have to be disciplined when you're working on the code. For me, caring about the quality of the code is super easy. Discipline is hard. Discipline is sitting down and saying, OK, I'm not going to do the 5-minute fix for this that I know I could do and then go work on more interesting things. I'm going to sit here for an hour and really solve the underlying problem. And that's hard. And it takes time. And as a developer, you have to fight for that time because your managers aren't going to want to give it to you. It does take extra time. This is the other thing that's sort of glossed over in all those studies. Doing TDD, doing unit test automation takes longer up front every single time. The time is more than made up for on the back end when you have so many fewer defects. But it does take extra time, and you have to fight for it. If you're going to care and have discipline, you have to care, or you have to take the time. Yes?
Just so you talk about the extra time thing, that study that you mentioned at the beginning,
Yeah.
they found that it took 20 to 40% extra time.
Yes, exactly.
So I would always say to people, you want to fudge the numbers for your boss, you tell them 1 extra day a week will have 90% fewer bugs.
There you go. 1 extra day a week, 90% extra bugs. Thank you. Did I say more? Fewer. Fewer. Whew. Oh, great. I'm so glad that was captured on camera. So, yeah, fight for that time. And you're still going to end up with spaghetti. This is the other thing. Like, don't think of yourself as a failure if you do have to do the 5-minute fix, because you do have something else that's more important that you need to work on, and you just don't have time. And that's fine. You're going to have spaghetti. It's OK. Just refactor it later and do the testing. And that is all that I have. Any questions or comments or concerns? Yes?
How do you keep your existing app from breaking while you're refactoring to make it more testable?
So the question was I'm remembering to repeat the question. The question was, how do you keep your existing app from breaking while you're refactoring it to make it more testable? Yeah. A lot of that was covered in the keeping the interface the same. As you're doing this stuff, don't change interfaces if you don't have to. If you want to do like a huge refactoring project where you are taking common.php and just wholesale turning it into something that's beautiful, go for it. That's going to break a lot more, so that's a much bigger project.
Mostly what I'm asking about is like they use like Selenium or something to drive the browser.
Absolutely. Yeah, so the comment was you could use Selenium or some end-to-end testing framework to sort of confirm that your stuff is still working as you're refactoring. And yes, definitely use Selenium, throw it into Sauce Labs.